Cambridge type gauge is a simple tool that allows you to perform several different types of measurements of welds. With this one tool, for example, you can measure undercuts or pits, fillet weld leg length, fillet weld throat dimension, weld reinforcement, outside misalignment, and angle of preparation. To measure undercut or pits, place the tip into area of undercut and lower the legs of the gauge to the surface of the plate. The amount of undercut is read from this scale. To measure fillet weld leg length, place the tip at the toe of the weld. Again, lower the legs of the gauge to the surface of the plate and read the actual leg length from this scale. This measurement should read 3/8 of an inch for this weld. Now let's measure the actual fillet weld throat dimension using the miter slide on the Cambridge type gauge. First, extend the slide as far out as it will go. Place the tip of the slide on the face of the weld and lower the gauge until it squarely contacts the surface of both plates. The actual throat dimension is then read from this scale. Now let's try measuring the weld reinforcement. Again, using the tip, place it at the highest point on the weld and lower the legs of the gauge to the surface of the plate. The weld reinforcement dimension is then read from this scale. To easily measure outside misalignment in a similar manner, rest the legs of the gauge squarely on one surface of the pipe and lower the tip until it contacts the other pipe. Again, this scale is used to read the amount of misalignment. Finally, let's measure the angle of preparation of this pipe spool piece. Place the legs of the gauge squarely on the surface of the pipe and lower the rotating segment until it rests squarely on the bevel. This bevel angle measures approximately 37½ degrees according to the scale. One of the quickest and easiest ways to check fillet weld size against weld specifications is with a fillet weld gauge. These gauges come in a set with sizes ranging from 1/8 of an inch to 1 inch in size. Just select the size that's called for in your drawing. In this case, the size selected is a 3/8 of an inch gauge. This part of the gauge will measure the height of the fillet weld leg. Here is another type of weld gauge called the AWS gauge, which performs some of the same functions as the Cambridge type gauge. With this gauge, you can measure actual fillet weld leg length, size of concave fillet weld, permissible convexity, and reinforcement. To measure the actual fillet weld leg length, place the side of the gauge squarely against the side of the plate. Lower the gauge until the leg contacts the toe of the weld. Now lower the slide until it contacts the other plate surface. The actual leg length is read from this scale. To measure the size of a concave fillet weld, place the gauge so that the 45-degree bevel rests squarely against the adjoining plate surfaces. Now carefully lower the slide until it contacts the face of the weld. Read the effective weld size from this scale. Again, place the 45-degree bevel of the gauge against the adjoining plate surfaces to measure the permissible fillet weld convexity. Lower the slide to the weld throat and read the maximum convexity from this scale. Finally, let's measure the reinforcement of a butt weld. Place one leg of the gauge on each plate and lower the slide until it contacts the weld reinforcement. Measure the permissible weld reinforcement from this scale. This scale is designed to measure weld reinforcements ranging from a minimum of 1/32 of an inch to a maximum of 1/8 of an inch. The high-low welding gauge is another multi-purpose gauge. As with all of the gauges shown in this program, both standard and metric units of measurement are available for dimensional verification. With the high-low gauge, you can measure internal misalignment after fit-up, material thickness after fit-up, verify 37 1/2 degree bevel angle, fit-up gap after fit-up, and butt weld reinforcement. Let's start with an internal misalignment. First, loosen the locking screw and insert the gauge tip into the fit-up gap. Now rotate the gauge 90 degrees and slide the gauge body until it makes contact with the outside diameter of the pipe. This assures that the gauge is square and that the reading displayed is correct. Next, pull down the gauge until the internal alignment stops are snug against the inside of the pipes. Read the misalignment on the scale. You can use the same procedure to measure pipe wall thickness after fit-up. To obtain this measurement, use the material thickness indicator and this scale. To measure fit-up gaps less than 1/16 of an inch, insert the alignment stops into the fit-up gap. If the thinner portion of the gauge will not fit, then the gap is less than 1/16 of an inch. If it partially fits the gap, then the gap measures somewhere between 1/16 of an inch and 3/32 of an inch. If the stops go through the gap is larger than 3/32 of an inch. This procedure can also be used to verify a 37 1/2 degree bevel angle. Before you insert the gauge this time, be sure to set the alignment scales to the 0 position. Now place the gauge body squarely against the pipe wall. Push the gauge as far as it will go into the fit-up gap. If the beveled shoulders on the gauge fit snugly against the bevel on the pipe end, you have the correct 37 1/2 degree bevel, common to most pipe end preps. We can use another procedure to measure fillet weld leg length and butt weld reinforcement. Place the gauge over the fillet weld and read the actual fillet weld leg length on this scale. This same procedure can be used to measure butt weld reinforcement. This single-purpose high-low gauge performs several of the same functions of the high-low welding gauge. With this gauge, you can measure internal misalignment and fit-up gap after fit-up. First, we'll measure an internal misalignment. Loosen the retaining screw and extend the legs beyond the housing of the gauge. Now insert the legs into the fit-up gap and rotate the gauge 90 degrees. With the gauge housing held squarely against the pipe wall, the internal misalignment can be read from this scale. We can use the opposite end of the gauge to measure the fit-up gap. First, loosen the retaining screw and insert the gauge into the gap so that the leg with the less taper will rest on the pipe bevel. The other leg can be extended until it contacts both pieces of the pipe. Now tighten the retaining screw and remove the gauge to read the fit-up gap measurement on the scale. The VWAC gauge is a tool which allows you to perform several different types of measurements and to compare weld defects. With this tool, you can measure undercuts or pits, reinforcement of butt welds, outside misalignment, surface porosity per linear inch, and compare surface porosity for size. To measure an area of undercut, set the bottom of the gauge on the base material. Set the tip of the pointer into the area of undercut and read the amount of undercut from this scale. The locking screw can be tightened to hold readings for future references. To measure the weld reinforcement of a butt weld, set the bottom of the gauge on the base material and set the tip of the pointer on the top center of the butt weld. Read the height of the weld on this scale. To measure outside misalignment, set the bottom of the gauge on one member or spool piece. Extend the tip of the pointer to the adjacent spool piece and press the tip of the pointer up or down to make contact. The reading from this scale will give you the amount of misalignment. To measure a line surface porosity in 1 linear inch, place the end of the gauge with the scale along the length of the weld to be examined. Read the amount of aligned pores in 1 linear inch from the scale with 1/16 of an inch increments. To compare surface porosity for size, place either the 1/8 inch or the 1/16 inch hole in the gauge next to the pore in the weld to be checked. Compare the size of the pores to holes in the gauge. The adjustable fillet weld gauge was designed so that just one gauge can be used to check 15 different sizes of fillet welds, equal or unequal in size. With this gauge, you can measure fillet weld leg lengths from 1/8 of an inch to 1 inch in 1/32 of an inch increments. Desired throat thickness of fillet welds. And unequal-legged fillet welds. The strength of a fillet weld is based on the effective throat thickness, which is the shortest distance from the root to the face of the weld. For an equal leg, 45-degree fillet weld, the throat is 707 thousandths, which is the sine of 45 degrees times the leg size of the weld. To measure equal-legged fillet welds to size, as required from drawings or specifications, select the appropriate size. In this case, a 3/8 of an inch fillet weld is required. Set the 45-degree slide at 375 thousandths of an inch, or 3/8 of an inch on the scale. Place the gauge on the horizontal member. Slide forward until the bottom of the irregular curved portion touches the toe of the weld. At this point, the bottom of the 45-degree slide will contact the toe of the weld on the vertical member, which indicates that a 3/8 by 3/8 of an inch fillet weld has been verified according to specifications. To measure throat thickness, a welder must determine weld leg sizes. If 3/8 of an inch fillet size is required, use 707 thousandths times leg length formula in determining the throat thickness. For example, 707 thousandths times 375 thousandths equals 265 thousandths. Round this off to the nearest fraction in 1/16 of an inch, which would equal 250 thousandths, or 1/4 of an inch throat thickness. To determine this measurement, move the slide to the center of the gauge at the throat and check position. Extend the pointer to 250 thousandths of an inch and lock the screw. Place the gauge so that the 45-degree legs touch horizontal and vertical members. The point of the extended slide should just touch the face of the throat as shown in this example A. If it does not touch as shown in the example B, more weld is required. To measure unequal-legged fillet weld size, determine from specifications the size required. In this case, a 1/2 inch by 3/8 inch weld is required, as shown in example C. Set the 45-degree sliding scale at a 1/2 inch and set the small back scale at 1/8 of an inch and lock the screw. Then proceed in the manner just described for the equal-legged fillet weld. Another type of weld defect encountered is undercut that is transverse to the primary stress in the part that is undercut. To measure this weld defect, the weld transverse primary stress, or WTPS, undercut gauge is used. To measure undercut, place the gauge on the surface of the member next to the undercut area. Insert the 10/1000ths tip into the undercut. With the aid of illumination, determine if light can be seen between the parallel surfaces of the gauge and the base material. If light can be seen between the two parallel surfaces of the gauge and the base surface, the area is acceptable. If no light can be seen, the area is just at 10/1000ths or rejectable. The WTPS gauge kit includes a precision calibration block for periodic calibration. The final gauge demonstrated in this program will be the skewed T fillet weld gauge with calculator. Normally, we think of members being welded together at a 90-degree angle to each other. A special condition exists when members come together and are welded at angles other than 90 degrees, and fillet welds are used to make the connection. These conditions are called skewed T-joints. The angles involved usually are at a 60-degree angle minimum on the acute side and 120-degree angle on the obtuse side. The 60-degree minimum angle requirement is specified on the acute side of the joint to allow for access of the electrode by the welder. Here we are measuring the W dimension of a fillet weld in the skewed T-joint from the obtuse side of the member. Here we are measuring the W dimension of a fillet weld in a skewed T-joint from the acute side of the member. The W dimension that is used for the inspection of the skewed T fillet weld sizes can easily be found by using the calculator. Leg size can also be obtained by using this method in conjunction with the gauge. This concludes the presentation of the various weld inspection gauges used by the personnel responsible for the dimensional requirements in conformance with the National Welding Standards.